Have you ever been in a situation where something felt so profoundly unfair, so completely wrong, that you just had to react? Even if standing up for what was right meant you'd actually lose out personally, like that gut feeling telling you, this cannot stand.
Oh, absolutely.
Today, we're diving deep into that powerful, often perplexing human instinct.
It's a truly fascinating area because it challenges one of the foundational ideas in economics, Homo economicus. That's the traditional view, that humans are always purely rational, self-interested beings, constantly looking to maximize their own gain. But our gut reactions to unfairness, they often throw a wrench in that whole theory, don't they?
They absolutely do. And that's our mission today. We're pulling back the curtain on the neurobiological basis of unfairness. We're going to explore this using the insights from some truly remarkable research, a massive meta-analysis that crunched data from over 3,200 participants, gathered over a quarter-century of studies.
Wow, that's a lot of data.
It's an incredible body of knowledge, helping us understand how our brains react to injustice. We'll specifically zoom in on the roles of two powerful moral emotions, disgust and anger, and explore if they share a kind of common socio-emotional core when we confront something unjust.
And a cornerstone for studying these reactions in the lab is something called the Ultimatum Game.
Yes.
It's a simple setup, yet it brilliantly reveals how our emotional brain can often override what looks like pure self-interest. People famously reject unfair offers in this game, even if it means they end up with absolutely nothing themselves.
Okay, let's unpack this game. It's deceptively simple, but its revelations are anything but.
Okay, imagine two players. Let's call them Player A and Player B. Player A, the proposer, is given a sum of money, say $10.
Right.
Their task is to offer a split of that money to Player B, the responder. Player B then has a choice. Accept the offer, and the money is split as proposed. Or reject it, in which case neither player gets a single cent. The entire $10 vanishes.
So if you were that purely rational Homo economicus we just talked about, and Player A offers you just $1 out of 10, you'd take it right.
Logically, yes.
$1 is better than nothing. It's a free dollar. But what actually happens when people play this game, and what does that tell us about human behavior?
Well, here's where it gets truly fascinating. Despite the rational choice being to accept any offer greater than zero, responders often reject offers they consider unfair, especially anything below, say, 30% of the total.
Even 30%?
Yes. They'd rather both get nothing than let an unfair proposer walk away with most of the money.
It seems completely counterintuitive at first glance. Why sacrifice your own game just to punish someone?
Exactly. That's the classic irrational rejection that sparks so much study.
So what's driving this powerful, self-sacrificing urge to enforce fairness? Is it just stubbornness or something deeper?
It appears to be driven by powerful negative emotions, primarily anger and disgust. We have a mountain of behavioral evidence for this. For example, those small, unfair offers reliably trigger strong feelings of both anger and disgust in responders.
Okay.
What's more, studies show that even subtle facial expressions of disgust increase as an offer becomes more unequal, and those expressions actually predict a higher likelihood of rejection.
Wow. It's like your face is telling the story of your moral outrage before you even make a decision.
It really is. That's incredible. Your physical reactions are practically screaming unfair.
And it goes deeper. Researchers have even found that if you prime people with feelings of disgust or anger before they play the game, maybe by showing them certain images or having them recall specific memories, they perceive offers as more unfair and are more likely to reject them. It sets the emotional stage for their reaction.
Exactly. It preconditions the response. Another neat finding is what we call the cooling off effect.
Cooling off.
Yeah. If you introduce a time delay between an unfair offer and the responder's decision, it can actually reduce rejections.
Okay. Makes sense.
Those initial strong negative emotions, especially anger, have a chance to subside. But here's the kicker. If during that delay, you actually encourage people to ruminate, to keep thinking about how unfair the offer was,
Oh, no.
rejections actually shoot back up, fueled by that sustained anger. It's a perfect example of how our emotions can simmer or cool, influencing our choices.
So it's not just about the numbers, it's about managing that emotional heat. I suppose that's scientific proof that I should never send an angry email right after I receive one.
Haha, probably good advice. Conversely, If responders are given a chance to express their negative feelings, say, by sending a message to the proposer,
Like venting.
exactly like venting, their acceptance rates for unfair offers can actually increase.
Interesting.
This suggests that rejection is often less about the money and more about the need to express that powerful moral disapproval.
That makes a lot of sense. It's about the feeling.
That's precisely it. It's about the feeling. And this isn't just a uniquely human quirk. We see evolutionary roots in other species.
Really? Like what?
Non-human primates, for instance, show a basic sensitivity to unfairness. They'll react negatively if they see a partner getting a better treat for the same task.
The famous capuchin monkey study with the grapes and cucumbers.
That's the one. But what appears to be uniquely human is this idea of costly punishment, where we're willing to pay a price to enforce fairness norms.
Though we'll sacrifice our own gain.
Right. This behavior, surprisingly, even shows up in young children. It highlights how deeply ingrained this drive for fairness is in our social evolution, helping us maintain cooperation and order within society.
Given this fascinating behavioral and evolutionary evidence, the natural next question is, what's actually happening inside our heads when we feel this way? Let's venture into the brain itself and map out the territories involved in processing injustice.
Okay.
What does your brain tell us about unfairness?
Well, research shows that when you're confronted with unfairness, it doesn't just activate one spot in your brain. Instead, it lights up a widespread network, a whole symphony of activity across both sides of your brain.
A network, right.
This unfairness network primarily involves regions in your insula, cingulate cortex, and prefrontal cortex,
Okay.
with a specific area called the dorsal striatum playing a key role in the ultimate decision to reject.
So let's zoom in on some of these key players. First up, the insula, often called your gut feeling indicator. What's its special role here?
The insula, specifically its anterior and middle parts, acts like a central hub for processing negative emotions. Think of it as your brain's alarm bell for anything unpleasant or aversive.
Okay, the alarm bell.
It's heavily involved in generating those powerful feelings of disgust and anger we talked about, and it's a major driver behind the impulse to punish.
But it's more than just raw emotion.
Yes, it's more sophisticated than just raw emotion.
Yeah.
The insula also monitors deviation from norm expectations. It flags when something isn't as it should be, according to your social rules.
Oh, okay.
It integrates your body's internal signals, that knot in your stomach, your heart racing with your conscious feeling of unfairness.
So it's connecting our physical reactions to our moral judgments.
Very interesting. And what about the cingulate cortex? What's its function in this network?
The cingulate cortex acts like a kind of conflict monitor. The anterior part, or ACC, is crucial for detecting that internal tension.
Yeah.
For example, the conflict between your immediate self-interest taking the money
Right.
and your desire to restore fairness by rejecting an unfair offer.
The internal struggle.
Exactly. The middle cingulate cortex, MCC, also steps in to process social information and monitor the outcomes of your decisions in these interactions. It's constantly evaluating if your actions align with your social goals.
And then there's the prefrontal cortex, often seen as our brain's CEO, our moral compass. How does its different departments weigh in on this fairness debate?
Exactly, the CEO. You've got several important players in the prefrontal cortex involved. Regions like the dorsolateral and ventrolateral prefrontal cortex are crucial for behavioral control and enforcing social norms.
The dorsomedial prefrontal cortex gets involved in assessing the intentions of the person who acted unfairly. Did they mean to be unfair, or was it an accident?
Ah, that's a key distinction.
It is. And the orbitofrontal cortex helps regulate emotional responses and can even help us suppress our own self-interest when upholding fairness is more important.
So they work together.
Together, these areas help us make complex moral judgments and decide how to act.
Now here's where it gets really intriguing. The dorsal striatum. This region typically lights up when you get something good, right? Like a reward.
That's right. A bonus at work, a delicious dessert.
So what's it doing when we encounter unfairness? Seems counterintuitive.
That's the paradox. The dorsal striatum is usually associated with reward processing. But when confronting unfairness, its activation suggests that punishing the norm violator is itself rewarding enough.
Rewarding.
Yes, rewarding enough to actually override any personal monetary gain. Imagine you've been offered a ridiculously low amount in the Ultimatum Game. You reject it, getting nothing. But that burst of satisfaction you might feel, that's your dorsal striatum lighting up, telling you that upholding justice was its own kind of reward, maybe even more satisfying than the money itself.
It's like your brain gets a little justice high.
A justice high. I love that. That's a great way to put it.
Beyond these individual regions, our sources suggest that unfairness engages large-scale brain networks. What are these triple networks and why are they so important?
Yes, unfairness doesn't just activate isolated regions, it triggers a full symphony across interconnected networks. These include the salience network, the frontoparietal network, and the default mode network, or DMN.
The triple network.
Right. Instead of just one alarm bell, unfairness triggers an entire orchestra of attention, decision-making, and self-reflection.
There's a bigger response.
Much bigger. Their collective engagement points to how our brain handles salient, attention-grabbing, motivational, driving action, and cognitive appraisal, evaluating the situation processes all at once when faced with injustice.
So it tells us that injustice isn't just an emotion, it's a full brain mobilization.
Precisely. It's a complex cognitive and emotional event.
To understand what our brain is truly doing in these moments, researchers use a technique called functional decoding. How does that work, and what does it reveal about the unfairness network?
Think of functional decoding like a brain activity translator. Researchers feed patterns of brain activation into a huge database, like Neuroscience.
Okay.
And the database tells them these patterns are usually linked to processes like X, Y, or Z.
So it connects brain activity to known functions.
Exactly. What this technique reveals for the unfairness network is fascinating. The top terms that pop up are things related to norm violation, which includes error, conflict, and inhibition.
Norm violation. Makes sense.
Along with decision-making and salience, encompassing terms like negative feedback, risk-taking, and losses.
Okay, so quite a mix.
What this really shows is that our brains don't just feel unfairness. They actively compute it as a social error, a conflict that demands a decision, and something that screams attention.
It's less a passive feeling and more a call to action.
Exactly, a cognitive alarm.
And is there a neurochemical link here? Something that ties this all together?
Absolutely. There's a specific link with serotonin, a neurotransmitter that plays a crucial role in mood, emotion, and behavior.
Serotonin, right.
Research shows a correlation with the 5-HT1B serotonin receptor. This suggests that serotonin plays a role in the effective sources of irrational, costly punishment behavior, linking those emotional reactions directly to the decisions we make.
So it connects the feeling to the action.
It seems to be a key piece in understanding the biological underpinnings of our fairness drive.
So, we know unfairness activates a lot of brain regions and is driven by powerful emotions like disgust and anger. But does our brain process anger and disgust in exactly the same way when facing unfairness? Or are there subtle differences?
That's a brilliant question.
Do they just blend together, or do they have distinct neural signatures?
That's something this meta-analysis allows us to dissect their unique brain patterns. Let's start with the core disgust network.
Okay, core disgust.
This acts almost like your brain's ancient defense mode. It's activated by things like potentially poisonous food or bodily fluids.
The real yuck factor.
Exactly. Its key regions include the amygdala, your brain's threat detector, the parahippocampal gyrus involved in memory, our familiar insula, and parts of the prefrontal, parietal, and temporal cortex.
So this is your brain's evolutionary defensive avoidance circuit. It's designed for detecting early threats and initiating defensive responses. The amygdala, for instance, is flagging those aversive signals. Your visual cortex is processing the emotional content, and motor regions are getting ready for withdrawal. Think, get away from that rotten food.
Precisely. Functional decoding for this network brings up terms like threat, avoidance, disgust, and suffering.
Makes sense.
And interestingly, it correlates with specific serotonin receptors, 5-HT1B and 5-HT2A, reinforcing its role in processing deeply unpleasant, aversive experiences.
Okay, so that's disgust, the defense mode. What about anger?
Now let's switch gears to the anger provocation network, which is more akin to a fight mode reaction.
Fight mode, okay.
This network involves our trusty anterior and middle insula again, along with the ventrolateral prefrontal cortex, the left thalamus, which acts as a sensory relay station,
The thalamus?
the right middle cingulate cortex, the dorsomedial prefrontal cortex, and once more, the dorsal striatum.
Still some overlap, but different players too.
Yes. This network is all about the subjective experience of anger, that fiery feeling. The thalamus helps facilitate salience and stress responses, making us acutely aware of the provocation.
Right, makes you pay attention.
The MCC tracks how intense that provocation is, and the DMPFC captures that self-referential anger you feel, that sense of being personally wrong.
Like, how dare they feel like?
Exactly. The dorsal striatum, as we know, is involved in coding those provoking stimuli, fueling that desire to react.
Okay, and the decoding terms.
When decoding this network, we see terms like negative, salient, and surprisingly, pain.
Pain. Interesting.
Suggesting a strong connection between anger and pain, with anger sometimes even inhibiting pain expression. It's also correlated with the 5-HTT serotonin transporter, supporting its biological plausibility.
So to directly address the question, what really distinguishes these two emotions when it comes to unfairness?
Okay. When we isolate brain activity that's stronger for unfairness compared to core disgust, we see higher engagement in areas like the ACC, MCC, DMPFC, DLPFC, OFC, the insula, and the left dorsal striatum.
So a lot of those higher level cognitive areas.
Exactly. This cluster points to a higher burden of social cognitive processing and conflict resolution, unique to dealing with social norm violations, things like betrayal or cheating, compared to just a pure physical disgust stimulus.
Right, so unfairness engages more of our thinking and social processing brain when the trigger is social compared to basic disgust. What about anger?
On the flip side, comparing anger provocation greater than unfairness shows stronger activation in the left thalamus, primary somatosensory cortex, and the insula.
More sensory and relay areas.
Right. The thalamus and those motor-related areas seem distinctive to the immediate visceral experience of anger provocation itself, that sudden surge of heat or tension in your body.
So while both disgust and anger make us feel bad and drive reactions to unfairness, your brain is actually using quite different pathways depending on whether it's processing a threat to your body like core disgust or a challenge to your social standing that provokes anger.
That sums it up nicely. Different flavors of negative reaction.
Now that we've seen the distinct paths for disgust and anger, let's explore where these powerful emotions intertwine, where they share a common purpose. It sounds like the insula is a central player here, acting like a real key node.
Absolutely. The bilateral anterior and middle insula consistently light up across all three scenarios we've discussed: unfairness, core disgust, and anger provocation.
All three?
Yes. This makes them a critical interaction point, signaling a shared negative emotional reaction to norm transgressions and other aversive stimuli. It's a bit like a common alarm button that gets pressed for different kinds of threats. From an evolutionary perspective, this suggests that the brain's mechanism for processing basic core disgust-like encountering contaminated food likely pre-adapted to handle more complex socio-moral disgust and anger in social contexts.
It's an ancient defense system getting repurposed for social justice.
That's a great way to think about it.
That's a powerful idea. Our brain's basic yuck response evolving into a nuanced sense of right and wrong. Are there other shared regions or networks involved?
Yes. Beyond the insula, the ventrolateral prefrontal cortex and the orbitofrontal cortex also show overlapping activation for both unfairness and core disgust.
Okay.
This reflects a more general negative emotional response to various aversive stimuli. And at the network level,
The big network.
right, both the salience network, which helps us detect anything behaviorally or socially relevant, including morally charged information, and the default mode network, which is important for moral cognition and emotions, show convergent involvement when unfairness blends with either disgust or anger.
So they help flag the problem and reflect on it.
Exactly. They're helping us identify the problem and then reflect on it through the lens of our personal values and past experiences.
And the serotonin link we touched on earlier, does that resurface in this shared core?
It does, even more powerfully. We find a shared serotonergic basis involving both 5-HT1B and 5-HTT for unfairness when it's mixed with both disgust and anger.
Both. Interesting.
This further suggests serotonin's vital role in mediating emotion and moral judgment and driving that costly punishment behavior. It's a key biological thread connecting these powerful emotional responses.
And here's the real aha moment from the behavioral decoding, I think. When we functionally decode the brain activity common to unfairness and disgust, and then compare it to the activity common to unfairness and anger, the results are remarkably similar.
They are indeed. It's quite striking. Both conjunctions reveal terms like norm violation, decision-making, salience, engagement, stop, error, and conflict.
Wow, almost identical lists.
Very similar. This suggests that even though we might distinguish between anger and disgust in our everyday language and subjective experience, right,
When it comes to social morality, when a norm has been violated and something needs to be done about it, your brain sees a common core, a unified signal for action.
A core something is wrong signal.
Precisely. Even disgust and anger provocation themselves show shared activation in the left anterior and middle insula and the salience network, reflecting a domain general processing of negative stimuli alongside motor planning regions.
So they might feel different, but deep down they're both telling your brain, something is wrong, react.
That's the essence of it.
So what does this all mean for us? Our deep dive has shown us that your brain's reaction to unfairness is far from simple. It's a complex, beautifully orchestrated interplay of specific cognitive and emotional processes, robustly engaging powerful regions like the insula, the cingulate cortex, and the prefrontal cortex.
And this research provides compelling neurobiological evidence for what are known as appraisal theories of emotion.
It confirms that our emotional responses, those gut feelings of disgust and anger, are not just passive reactions. They are actively shaping our moral judgments and even driving our costly punishment behavior. They're telling us what to value.
And it definitively challenges the Homo economicus model, that idea that we're always purely rational maximizers.
Absolutely.
This research powerfully demonstrates how emotions fundamentally drive our decisions, even when it means personal sacrifice to uphold a sense of fairness. Our brains are truly hardwired for justice, it seems.
Indeed. Knowing that our brains are hardwired to react so strongly to unfairness, even drawing on ancient defensive systems. Well, what does this tell us about the fundamental human need for justice? It speaks to a deep primal demand for equity in our social contracts, I think.
And more broadly, how might this deep understanding of our brain's emotional logic help us build more equitable societies, or maybe even navigate our own interpersonal conflicts?
That's the big question, isn't it?
Perhaps by recognizing that the powerful emotions of anger and disgust aren't just destructive forces, but ancient signals pushing us towards a more just world. It's something truly worth reflecting on, isn't it?
Definitely something to think about.